So looking at our first example, we're just going to analyze one graph at a time. And so when you look at this graph, the first thing you want to do is you want to label pertinent points. I have endpoints here, one's open, one's closed. I have a maximum, relative minimum. So the first thing I'm going to want to do is I'm going to want to label these points. And so by doing that, we've established where they are. Notice that some of the points are nice and even numbers, like that point is 1, 2, and this point is 4, -3. But I want to look at this minimum. This minimum may be at -1, but it's only about halfway through. So I would just estimate maybe a tenth here. That's going to be -1.5 or 0.5. And this point over here, I'm estimating it to be -4.4 and then +4.2 for the output value. So make sure you have organized that before you start trying to answer the questions that are presented. So let's take a look at the first question. Using interval notation, state the domain and range of the graph. So to do this, and it's important to understand that you need to scan the graph going left to right. So if I scan the graph going this way, right, the graph starts at this point, it keeps going, keep going, and it would end here. So I just use those input values. I would use this input value and then this input value because the domain is input values. So the domain would be the numbers -4.4 and then comma 4. And then to use interval notation, since this is an open circle, I use a parentheses. And since this is a closed circle, I use a bracket. Everything is a bracket unless you see an open circle, and then it is a parentheses. So to do the range, what we're going to do is we're going to go from the bottom to the top. And so we will start here, but the range value is going to use the output value. So it'd start here, it keep going. Remember, we're going all the way through. It keeps going until we get to there. So the range value would be -3. Remember, ascending order, so that negative has to be first. And then it's going to stop at 4.2. And again, same idea here. The -3 is a solid dot, so it gets a bracket, where the 4.2 is an open circle, so it will get a parentheses. All right, make sure those parentheses look nice and parenthesis-like. If you need to erase one and make sure you don't get them confused, make sure you take the time to do that so you understand the difference. All right, so now we're going to list the intervals or the domains where f is increasing and where f is decreasing. So if I take a look at what's happening here, I like to use red for decreasing. The graph is decreasing, meaning if I were standing here, I would have to walk downward until I get to this point, which is the minimum, which we can actually go ahead and label in these other points in a minute. We've already labeled it as -1, 0.5. I also have decreasing intervals here because I would have to walk from left to right. Remember, I have to go left to right. So I would be walking down here as well. But in between here and here, I would walk upwards. Okay? So if I were to list the increasing interval is the domain of this little piece here. So that would be from -1 to 1. And when you list increasing and decreasing intervals, you always use a parentheses because you can't include those points. Now the reason is, okay, and this might look like a point to you, but in upper level math classes, this is read from -1 to 1, which is what we see here. The reason I can't use a bracket on this point is I'm about to then use it in the decreasing interval. So for the decreasing interval, what I'm going to do is I'm going to start my decreasing interval here at -4.4, and it's also going to include this point because it's going from here to here and then stopping right there at -1. So the problem is, okay, is that you cannot include this shared point right here at -1 because it's both here and here, so it needs a parentheses. Now this needs a parentheses for a different reason. It needs a parentheses because it is, in fact, an open circle. Okay, so now let's look at this last interval. Ask yourself, it starts at 1, it goes to 4. Is the 1 shared? Yep, it's right there. So I have to use a parentheses, but now ask yourself this very important question. Is that 4 shared? It is not. It also has a solid dot. So that will be an inclusive point because it's not shared between an increasing and decreasing interval. All right, so let's take a look at our mins and maxes. Some of them are labeled, and some of them we have to sort of understand exactly where they are. So the first ones that are probably the most obvious to label are the ones that are here. That is clearly a minimum or a dip, and this is a maximum or a peak. So that is my local, right? Those are local. So I'm going to go ahead and say my local or relative, however you want to say it. We'll say local. My local min and local max. Now, here's the thing about them, okay? There actually are more than just those two, and I'll explain why in just a second. So local min is -1, 0.5, and my local max is the point 1, 2. Now, where are the other ones? Well, believe it or not, this is a local max. The reason it's a local max is because I want you to think about if you were starting on a hike and this represented a hike. Wouldn't this be the highest point you were at? But the problem is, so that's a maximum, but the problem is it's not actually there because it's open. So since we can never decide exactly where this point is, we actually, even though it is a maximum, I can't include it in the maximum list. It would actually technically be undefined, which is really important for the global maximum. So when I look at the global maximum here, I would actually have to say that it is undefined. Undefined means basically open circle. So why is that happening? Well, we have to describe what's happened. We have to describe what we see in the graph. The graph is representing a maximum here, but I don't know where it is because it's open, meaning is it at -4.4 or is it at -4.39 or is it at -4.3999? We can never agree on it. However, we do know that it's there. So we don't list it in our local maximum, but we do say that our global maximum is undefined. Okay, let's take a look at the local minimum. We have a minimum here, and this is also a local minimum. Think about being on a hike. You would start, you'd go up, you'd go down, and you would stop right here. But that point is defined, so I can actually put it in my list for -3. And for my global or absolute, doesn't matter, those words are interchangeable. For my global minimum value, I'm going to list that point. So what is the difference between global and relative minimums and maximums? Relative or local are the list of everything you see. However, global max and global min, there's only one of those. There's only one tallest mountain in the world. There's only one lowest point in the world. There's one richest person in the world, right? So the global minimum or maximum, there's only one thing that'll be here. But over here, there could be a lot of them. It just depends on what your graph is doing. All right, let's take a look at some actual calculations. So this is where I'm going to start translating what these are saying because they're not super obvious for students when they first start out. When you look at this question, it says find f of -6. What this is asking you to do, it's saying what is the output value of f at each of these input values. So the best way to understand this question is to simply label these points. So if I were to go and find -6, which actually isn't here. So the first point we have is undefined. So f of -6 is undefined because the graph only has a domain of -4. Okay, so that's undefined. Another way to shortcut that, if you don't want to say is undefined, is you could say does not exist, otherwise known as D and E. It's one of the only math shortcuts that's allowed to be used. So f of -6 does not exist. So f of -1 is right here. That's that point. And so what is the output value of -1? It's 0.5. So the way you would write that is f of -1 is equal to 0.5. And that is the answer. The answer is that. So what is f of 3? Let's take a look. F of 3 is here, and so this one we actually have to maybe kind of estimate where that output is. So I have a 3, and my estimated output would maybe be negative 1.5. You know, your teacher would probably be okay if it were off by a tenth, either below or above that number. So f of 3 would be equal to negative 1.5. And then again, if I look at f of 9, well, the domain only goes to 4, so f of 9 also does not exist. And so does not exist is not something we need to be scared about when we think about algebra or think about analysis of graphs. It's just something that happens when something is asked that is not in the domain of a function. All right, let's see if we can remember what this is asking. So it says, where is f of x equal to 0? Again, it's saying in English, what is the input value of f that has an output value of 0? And one way to think about that would be to draw a line at 0, but that's actually asking for the x-intercept, right? Because right here is 0, so it's actually asking for this point right here. So keep in mind, it really is helpful if you learn what these things are saying. Like this is the x-intercept, and then when you think about the next question, notice I just kind of changed it to try to remind you that this one is asking for the y-intercept. So it's important to know what these are saying because they come up a lot in Algebra 2. So the x-intercept would be written as a point, and that point would be, I don't know, it's a little bit past 2. So why don't we say 2.2? Again, if you were off by a tenth, your teacher would be fine with that. You could also say x equals 2.2 because it does ask for the input value. Both these would be acceptable, but maybe keep with the fact that it's the x-intercept. The y-intercept is right here, so that's right at that point, and that point is 0, 1. Another way to say that, if you were to see that, would be f of 0 equals 1, meaning I inputted 0 and I outputted 1. All right, so let's keep on this concept and look at a couple other ideas. So looking at this graph, when I look at these problems are asking me, where does f of x equal 3? That's asking me, where is the value of the graph equal to y equals 3? So that's basically, instead of saying 3, it's really saying, where does f of x, the graph, equal the line y equals 3? So if I take a line and I put it up at y equals 3 right here, it becomes pretty easy to understand what's happening, right? Because when I look right there at that line, so the graph f of x, the black graph, is equal to 3, the orange line, right there at that intersection. So once I see that and understand what it's actually asking, I can clearly see the answer. And again, labeling is just so important. And so what is the x value of that point? Let's see, negative 3.5. So the way I would say that is x equals negative 3.5. And again, if I were to label that point would be negative 3.5 comma 3, again yielding that concept that it wants me to look at 3. So this next one says, where is f of x less than 3? So that's actually asking, where is it below 3? So that's asking for a domain because it's below 3 this entire time here. The whole domain after the point negative 3.5. So negative 3.5 is where it begins to be below 3, and it stops being below 3 at 4 when the domain ends right here. And since this does not have an equal sign, I would use parentheses the whole time. If it did have an equal sign like that, that would make these brackets. So just keep that in mind, that some things in math are very subtle, and one of the most important, people will ask me all the time, why do I need to learn math? It really makes you pay attention very closely to details. I mean, think about that. Without an equal sign, I have to use parentheses, regardless of what the graph is saying. But with an equal sign, I'd have to use brackets. So just keep that in mind. It can be very, very subtle. All right, so the last one is the average rate of change. And the average rate of change is, again, it's a series of points, just like you had in Algebra 1, okay? So you just got to remember that it is, in fact, the slope. So to find this, what we're going to do is we're just going to label the points that they're asking us to find. So let's go, remember, this would be A. This is not a point. This is in a bracket. So this is an interval, and this would be B. So I'm going to go to -1, and I'm going to label that. Okay, thank goodness it's already labeled for me. So this would be A, and this would be f of A. So I already know those two things. They're right there on the graph for me. And then B, also labeled. First time you saw this in the graph, I wanted to have them nice and cleanly labeled. All right, so what I do now is I write down the formula and I simply substitute these numbers into that formula. So the formula is f of b minus f of a over b minus a. And again, I'm just going to go back to my graph. Okay, so f of b is 2 and f of a is 0.5. So 2 minus 0.5. We can go ahead and figure that out if we want. So 0 minus 2.5 is 1.5. All right, and then the input value b was 1 and the output value of a was negative 1. So it'll be 1 minus from the formula negative 1 because a was negative 1. That will come out to a positive, and so the denominator comes out to 2. And if you were to grab a calculator and take 1.5 and divide by 2, you would get 0.75 or 3/4. Either answer would be acceptable since it is a terminating decimal. Keep in mind that repeating decimals really, I don't know, it's probably a good idea. Fractions are never wrong, so it might be a good idea to say the answer is 3/4. So what that's saying is that between -1 and 1, the rate of change here, even though it kind of is curvy, the average rate of change on this interval is 3/4, or up 3/4.